So first thing we talked about on Friday was inverse trig, right? Anything that involves inverse trig. There's three of them that when you're finding the antiderivative, right? There's some relationships. We talked about how do I know that these relationships are going to be true? How do I know when do I look for these? Well, there's a couple things to look for. First thing is U substitution won't work. U substitution will not work for these guys. So if you see problems like this, you'll know pretty quickly because you'll try U substitution most of the time and it won't work. You'll have x's left over. So that's when you go to another set. Well, if it's got a square root and a minus, it's either going to be arcsine or arcsecant. Okay. If it's got something outside the square root in the denominator, then it's going to be arcsecant. If it's got a plus and squares, then you're looking at arctangent. Okay, those are the only three. We looked at the first one. If I was to use U substitution here, it wouldn't work. It would not work for this guy because I would make 1 minus x my u, and then I would find the derivative would be negative, du would be negative 2x, and I put it back in, there'd be x's left over, right? So that told us, hey, there's got to be another way. So we have squares, kind of difference of squares, 1 squared minus x squared, right? And we went from there. Same thing here. We didn't have squares, or we had squares, but they were plus. So that was arctangent. This one here, letter C, was the one I took off your circuit training. The one we didn't do. I gave you letter C on your circuit training. I gave you the answer. I said, don't worry about it. I'll teach you how to do it on Friday. And that's the one we did on Friday. So that's why it's 5 pi over 4. And then letter D was just indefinite, no bounds. Okay. And then the last thing we talked about was this thing called average value. Average value. So what average value tells us is where is the half of the data, where is half of the, not data, where is half of the area? Where along this am I going to get half of my value, half of my area, right? So for this guy here, it's pretty easy to tell. It's going to be somewhere in the middle, right? Because this guy, for the most part, is symmetrical, right? But then we have guys like this who aren't symmetrical. So it's not going to be somewhere in the middle. It's probably going to be somewhere over here. So what this guy here will tell you, the formula, is where that is. Okay? So we did some of those. We did one problem like that here. We started one problem, but we ran out of time. Okay, so originally we had this guy here. The integral from 1/2 to 9 over 2 for sine of pi over 3x. Okay. To find, and then it said we had to find average value, right? So we subtracted the bounds over here, top minus bottom, we got 1/4. Because 9/2 minus 1/2 is positive, is 4 whole. So 1/4. So then we did the rest. Everything else was the normal, what we usually do. That's the only part about average value that's different, is this guy out here. That's the only part that's different. Everything else is exactly the same as you guys have done before. Okay, so we said u was pi over 3x. We solved it that way. And then we got down to cosine u here. So now what I got to do is plug in pi over 3x. And then I'm going to plug in 9 over 2 and 1/2 and subtract them. Okay, so we've done the problem pretty much. We just haven't done the evaluation part. Okay. All right, so let's finish the problem. So first thing I got to do is plug back u in. So negative 3/4 pi. So u was pi over 3 times, the first one is going to be 9/2. minus the same exact thing, just instead of 9/2, it's 1/2. Okay. Evaluate it, finish it out. Once we get an answer for both, subtract them, we're done. Okay. So over here, we have -3/4 pi times cosine. When I multiply these guys, well, I can do some, this guy will cancel out with that guy. So it's 3 pi/2. Okay. The other one is going to be done the same way. If I can simplify, I don't think I can simplify that one. So that one's just going to multiply straight across, and you'll get pi/6. Okay. So 3 pi/2, I got to go find cosine of 3 pi/2. What is cosine of 3 pi/2? 0. Okay, 0. Okay. Now, last thing, what is cosine of pi/6? First quadrant. Square root of 3/2. Positive root 3/2. So anytime you get 0, it's nice because it cancels everything out. This guy here is just going to completely go away because 0 times anything is just 0. So I have 0 minus, and then here I can do no, I can't even do any cross multiplication there, or cross canceling there. So I'm going to get -3 times root 3, and then I'm going to get 8 pi. Multiply straight across. I can't multiply the 3 and 3 on top because one is a 3 and one is a root 3. Those aren't the same thing. 3 is regular 3 whole. Root 3 is 1.4, 1.5 something. So it's not actually a 3. So I can't cancel those out or multiply them. These guys here, I just multiply straight across and I get that. I see that it's subtraction. So it's just going to be positive 3 root 3 over 8 pi. Okay. Done. Like I said, most of the time, the hardest part is going to be the evaluation part. But that part we've done many, many times before. Not even in this class. You've been doing it. You've been plugging in things for X and getting things for Y since probably 6th, 7th grade. So that part, like I said, is usually the most tedious, but you guys have done that before. Okay. All right, one more. One more, and then I'll give you some time to start on your assignment in class. So again, anytime they want you to do average value, they will tell you. They won't have you guess. It's not like a guessing game. They'll say, find the average value. Okay? And then they'll give you the function, and then they'll give you the bounds. Okay? And this one is a little even more because they want you to write the logarithm as a single number. So that means if it's natural log, ln, if it's a regular log, usually it'll be a natural log, and they only want one number in there. Okay, so we got to simplify it so that it's just one number in there. Okay, that's what they want. Okay, so set it up the way we always do. If we need to use substitution, we will. If not, we won't. Pretty sure we're going to need to on this one. You're going to have a fraction out in front. Okay. So our fraction out in front is going to be 1 over 4 minus 1. We're going to go from 1 to 4. And then our function is going to be 6 minus x, 6 divided by x minus 7. dx. When you're doing u substitution, not even u substitution, when you're integrating, when you're doing antiderivative, I always find it beneficial to separate fractions, especially if they're polynomial fractions. What do I mean by polynomial? They have x's, right? If it's a regular fraction, 6 over 1, 6 over 5, you don't need to separate it. But this one's a polynomial fraction because it's got that. So I always separate them first because that helps me see what is a constant multiple that I can move out in front and what is I'm going to do u substitution for. Okay. So when I do that, I get 1 over 3 in front, right? 6 times and then 1 over x minus 7. It says the same thing, but it's a little more clear as to what's going on here. 6 is just a multiple. I can move that to the front. So I'm going to do that. The next time I write it, I'm going to move 6 out in front to multiply with the 1/3. Okay, so I'm not worried about the 6. Okay. Now I have 1 over x minus 7. Right there, it's u substitution. I'm going to use u substitution for the bottom. Okay. So u substitution, I'm going to say u is x minus 7. Du is 1 dx. Divide by 1. I get 1 du equals dx. You don't need the 1 in front of the du. It won't do any difference, but technically it's there. Okay. So let me rewrite this now. So I have 2 out in front. How did I get the 2 out in front? Can someone tell me how I got the 2 out in front? Yeah, as well. Yeah, multiplying the 6 and the 1/3. Good. Okay. And then I have u, which is x minus 7. Du, I have a 1. I can plug in the 1, but it's not going to do anything. Either way, the 1 would come out here. Okay. We've seen this guy a lot. We've seen this antiderivative guy a lot, 1 over u. The antiderivative is natural log. So I have 2 times the natural log of u, and I have to evaluate that from 4 to 1. Okay. U substitution, or the antiderivative, the calculus part, if you will, is done. No more calculus part. The rest of it is plugging it in and seeing what we get as an answer. Okay, so the first thing I got to plug back in is u. So I'm going to do that over here. So 2 times the natural log, and I'll put u back in. And I have to evaluate that from 4 to 1. Okay, so I'm going to plug in a 4. Oh, also remember, the bars are there. Anytime you do natural log, the bars are there. The only reason they're there is when I plug in a number, it gives me a negative, because we can't have natural log of any number. If you don't believe me, use your calculator. If you try to take the natural log of a negative number, it's going to say error, it doesn't exist. So that's why the bars are there. If when you plug in, it's a positive number, you don't need the bars. But I can already tell when I plug in here and plug in there, it's going to be a negative number. Okay, so let me plug it in. First one, 2 times the natural log of 4 minus 7. So this one I'm going to need the bars because it's going to give me a -3. Probably should have wrote it down here, running out of room. And then 2 times the natural log of 1 minus 7. So when I simplify, I'm going to get -3. I'm going to get -3 in here. But because of the bars, it's going to make it a +3. So it's actually going to be +3 minus, over here is going to be the same thing. I'm going to get a -6. But because of the bars, it's actually +6. Okay. Okay, so now here's where we gotta use our skills to make one natural log. Right now I have 2 natural logs. I don't want 2 natural logs. I want 1 natural log. Okay? So the first thing I'm gonna do is, if you can do the power rule, do the power rule. I see that I have 2 2's out in front of them, right? Those 2's are gonna become the powers. That's the first thing I'm gonna do. I'm gonna move those 2's there. So when I rewrite it, I have the natural log of 3 squared minus the natural log of 6 squared. That gets rid of the 2's. Okay, so that's going to make the natural log of 9 minus the natural log of 36. Okay. Now the last thing to combine them, because I have 2 natural logs, right, and I have to have a single, is to combine them, not using this, but this will tell us that we can combine them using division. So that's going to look like this: the natural log of 9 divided by 36. Okay. The only other step is if I can reduce that fraction, reduce it, which I can. So it's going to be the natural log of 1 over 4. Done. Okay, I have one single natural log of something. That's it. Okay. Okay, so we have some time. I want you to start. We have quite a bit of time. We have 35 minutes. So you might even be able to get this assignment done. It's not very long, okay, because it's only covering 2 things. So you can use your phone to do Delta Math, or you can grab a Chromebook to do Delta Math, whichever one you want to do. It's on Delta Math. Okay, I'm going to post it right now, and if you guys have any questions, now's the time. You have me here. You have everyone in your class, the class here. Make sure you ask, and we'll go from there.